Hello and welcome to my channel. Today I would like to demonstrate the functions of the completed MouldKing MK 19016. It is a truck with loading chute and pneumatic crane. The model is a successor of the former model, where the crane was located at the end of the truck, and now the crane is located in the middle. It's a little bit difficult. I will show it in the demonstration. The complete dimension can be found in the original model description on the MouldKing homepage. The model itself has 10 electrical elements. It has one control servo. At first I thought it is not proportional, but during the driving test I've noticed it is. We have two large motors to driving the rear axle for driving, and you have at least 4 servos that are actuating the two-way pneumatic valves. You have one motor for turning the crane, and you have one motor for turning the supports, and one motor to tilting the loading chute. And they are organized in 2 battery boxes, a 6-channel battery box and a 4-channel battery box. So as you can see here, I'm driving the supports in and out. The supports does not have any force and can't lift the model. They're not intended to lift. They're only intended to give some side support during crane operation. Be a little bit careful when you drive them out and in, because as you can see here, the movement in the end is done by some yellow stars, I call it, and these stars are very fragile, and the gear behind are very strong, and if you put on the switch too long during movement in and out, the fragile yellow stars can break. So, but that's the only difficulty. For controlling, I'm still using for my ReadyMaster 16S. I've used in other models before, and it's for creating a convenient control experience by binding both battery boxes simultaneously to my controller and to freely assign the control elements. I've assigned all the pneumatic servo switches to the 3-way switches of the transmitter, and as you can see here, the space between the load area and the crane is very limited. I've put the loading box a little bit more to the rear to create some more space, but even it's still not very much space, especially because of the pneumatic hoses. They are positioned on top of the crane boom, but in the transport position, as you can see here, the hoses are folded inside to the gap, and it's only a little space, and the crane always needs some guidance. And the other problem is, in former models, you always have a lack of pneumatic power, and the pneumatic elements are not operating very well. And on this model, we have 2 pneumatic pumps and a pneumatic air pump. And in addition, because I control my my pneumatic pumps permanently, you have still enough pneumatic power pressure to operate all the pneumatic elements. But if you have the maximum pneumatic pressure present, the crane elements are always acting in nearly no time, no? And as a result, the crane elements are not very controllable. And for that reason, I have put 4 manual controlled pneumatic valves inside of the upstream and the downstream lines. I put them in the upstream lines to limit the speed of the forward movements or upward movements of the crane, and the more important, I've put them in the downstream lines to limit the speed when the rod is pushed inside of the cylinder. And because one problem here is due to the weight, when the crane boom is fully extended and the crane is placed in operation position, when you then open the valve for the down direction, not only the pressure that is applied to the downstream side of the cylinder is responsible for pushing the rod in. It is pushed by gravity, and for that reason you have to limit the diameter of the hoses to reduce the airflow, especially when you move the pistons in the rods inside of the pistons of the cylinders. And as you can see here, when I've not limited the speed of the clamp and of the boom extensions, and even when I extend the boom, as you can see here, this is the original speed when you have full pneumatic air pressure. No? And this is not very usual when you fold down the crane, or when you put the crane in operation position with two bottom cylinders or three bottom cylinders. You have two cylinders for the lowest crane support or arm, and one for the upper. And as you can see here, how fast the boom is extended, and when you retract it, due to the friction of the hoses in their guidance, they are not moving very smooth. Because they are rubber hoses and they always create a lot of friction. I've tried to solve it with a loop, but it does not solve it at all. But it is only a problem when you retract the boom, and you have to wait a little bit, and then when the air pressure is fully applied, then the cylinder is completely moved in. And that was a mistake when I at first have retracted the arm. The boom was not fully moved in. So now I will turn the crane a little bit in working position, and now we will play a little bit. No? And to have some kind of play factor, you have to create a little bit feeling when you open or close the pneumatic valves, and without the limit valves, so as you can see here, this is a movement without limitation. And if you haven't put some kind of airstream limiter inside of the upstream and downstream lines of the cylinders that are moving the main structure of the crane, you can't control. You have no chance to control it in the simplest manner. No? It has a digital function, only on off, and it's not controllable. And that was the reason why I've put the control valves in these lines. I can simply show you an image. No, wait a second. So we will. I have made some investigations which valve are suitable to limit the pneumatic flow, and in the end I've used the valve that is shown in the right lower corner. It is a reliable manual adjustable air valve, and it fits to the hoses of the model very well. And you can adjust it in a very fine way, because the problem is the dimension of the pneumatic hose is not very, very large. It's only 1 or 2 millimeters, and that makes it difficult to control the airflow in the good manner. And as you can see here, doing the demonstration. You can still play a little with the crane, but it's difficult to reach the whole area of the loading chute. No? But without the limitation, you can't do it in any way. And now you have to make some. You have to create some experience. No? You have to create a feeling which valve has to be closed in which manner, in which timing, and which valve has to be closed first, and which cylinder have to be rejected, which cylinder have to be extended. But I think this is the intention of the model, to play a little bit, to find your way, to deal with the functions, to be creative, and it works very smoothly and very nicely. So, and in the end, at first I thought, because the crane can reach the ground of the crane, and so for the play story, you can pick up some items lying next to the crane, but only directly next to the crane. Sorry. So now we will move the crane again fully upwards, and you can see this is because I've limited the upstream lines also. And as a result of the limitation valves, the crane is acting very smoothly. I've put the control valves behind the seats in the cabin. There was enough room to do so. I have used 4 valves, one valve for the lower 2 cylinders for the arm, for the crane arm, and one valve for the upper. Beziehungsweise, by the way, you need at least 2 valves per cylinder, or per section. One valve in the upstream line and one in the downstream line, and they are inside of the lines that support the upper and the lower cylinders for the main arm. I'm calling the main arm, not and the boom. They are not limited the airflow of the boom, but to the lower arm segments of the crane. No? I have little bit problems how to call the big cylinders. What is there moving? No. So again, the boom, not limited in the airflow, acting like a rapid whip. And now we will fold the crane into the transport position. At first we will retract the boom. Oh, wait a second, must have some air pressure to do so. So, okay, first I have to close the clamp. Now, when you have finished the work, you close the clamp. Now, then I will retract the boom, and then you will retract the upper crane arm. So, okay, we have to wait until the boom is completely retracted. Now we will lower the upper crane segment, but at first you have to turn the crane in the parking position. And the parking position always is 90-degree left-hand side. No? Also with the claw or clamp to the left-hand side. And when it's in 90-degree position, you can lower the upper arm segment. So, and because the flow is limited, it's not acting in light speed, so you can guide it a little bit. So the clamp the claw has some problems to turning aside the construction. So, as I told you before, it's the crane segments, when you extend it or retract it, they're needing some guidance. Without the airflow limitation, they does not need guidance, but then the crane acting like a boxer and punches. We have very thin punch when you extract or when you extend or extract the arm segments, no? And the chances you can damage something is very high. So now the lower arm is retracted. So you do not need to push it, only guide it a little bit. So now you only have to retract the support because finished working, and now we can drive. No? We can leave the construction site. So on the desk you have a little bit carefully. I have moved the truck one time from the desk, and therefore I have put the ladder in the background as resistance. So, but just for short demonstration, longer driving demonstration in the other video. So this is driving speed, you are leaving your working position, and that's for all. No? That's for all. That is the maximum speed. And at first I thought the steering is not proportional, but in the driving demonstration on the floor in the living room, I've noticed that the steering servo is some type of proportional. It does not have a linear function, and so I forgot to demonstrate the tilting function. I will show you the tilting function of the load chute. Well, I've put some debris inside, some bricks, and you can see here the tilting cylinder works very well. The problem is when you ask yourself why it's wobbling a little bit, the cylinder was damaged. No? So I have replaced them later, but for demonstration the function it was okay. And overall, I'm very satisfied with this model. I would like to add a reference model to compare it with some more expensive MOCs. And I think this model is a very well improvement compared to other MouldKing models with pneumatic functions. No? I like the control concept of this model. No? Even when you use a more intelligent control set like mine. But also if you used the original control sets, there can be very satisfied. I will explain it a little bit more. No? Because the model comes, to control the model, as I told you before, it has a 6-channel battery box and a 4-channel battery box, and therefore you have the 6-channel control and the 4-channel control. So the trick by finding a convenient control experience is the 4-channel box is assigned to all of the functions that have nothing to do with the pneumatic crane. One motor drives the support, one motor drives the steering servo, one motor is driving the tilting mechanism of the loading chute, and one channel is assigned to the 2 X-ray driving motors. And all of the functions of the pneumatic crane are assigned for the proportional controllable 6-channel box. And these are the on-off function for the 2 pneumatic punks, the turning motor for the crane, and at least the 4 servos that are only switching the pneumatic valve. And I find it more convenient to rearrange the electrical assignments, because when I use my control, the assignment of all of the 10 channels are done by software inside of my Radio Master control. And but if you don't want to spend such amount of money and you want to use the two controllers shown here, I find it more convenient to assign the 4 servos that are just controlling the pneumatic valves to the 4-channel box, and to assign all the elements that are for driving and steering to the 6-channel box. And to do so, you have to reroute the wiring, that's all. And then it works very nicely, I think. So, and yeah, that's all, and I hope for the short demonstration video you're fine with it. And because, as I told you before, I choose a more luxury version. You can find plenty of videos how RadioMaster or HTX or OpenTX controls are set up in other videos onto my channel. But the idea was how to use simple controls that comes with the model. Thank you for watching.